Okay, 4.4 deals with congruence and transformations. So talking about how different transformations form different congruent figures. One of the theorems that was in your student journal, if you check that out prior to doing your extra practice, talked about reflections in parallel lines. So if you took the image AB, reflected across line K, and then reflected that across line M, which is parallel to K, you would end up finding that the pre-image and the image are congruent, and reflecting across parallel lines is the same thing as what other type of transformation? A slide. Same as a translation there. And the distance you translated is actually twice the distance from or between those parallel lines. Okay? So that's one piece. And that's really what Theorem 4.2 is stating. Okay, so this distance from here to here is twice the distance of the length between the parallel lines. Okay, Theorem 4.3 talks about reflections in other lines. Now these lines, M and K, are intersecting. And if we take, say, it's a little harder to see this figure, but you take A to B, so segment AB reflected across line K, and then reflected again across line M, where line M and K intersect at a point. Right? This figure from A to B to A double prime, B double prime, what's the same as that if you're reflecting across intersecting lines? This is the same as a, you guys don't know. What does it look like? It does look like an angle. An angle of taking this figure and moving it to this figure. If we're not reflecting twice, what are we actually doing there? Yeah, we're rotating it. Okay, and the distance you rotate it is actually twice the angle measure that is formed between the two intersecting lines. Okay? All right. So, you guys were asked to complete your extra practice yesterday. Best you can. Numbers 1 and 2, I want you to compare your answers with your neighbors real quick. All right, let's see how you did on those. Identify all congruent figures in the coordinate plane. Okay, we have that ABCD is congruent to MNOP. We have EFGH congruent to STUV and JKL congruent to PQR. Explanations. Okay, you could talk about their side lengths being congruent. Okay, each side length is congruent. You could actually use coordinate geometry to figure out the side lengths. I didn't go through that, but talking about each side length being congruent. All angles and sides are congruent. How many got that one? Okay, number 2. Number 2, describe a congruence that transforms maps that maps PQR to STU. Now, the thing you really have to do here, and this one I think is one of the more difficult ones here. The thing you have to do, and let me put up a clean sheet here. Say on your original figure, note that when you look at PQR, so going alphabetically here, are you going counterclockwise or clockwise? When you're reading them, you're going PQR. That's counterclockwise. Okay? Now, in your image, so in your pre-image, you're going counterclockwise. So if you want, you can draw it up like that, or you can say counterclockwise, or however you want to make a note to yourself. In your image, STU, are you going counterclockwise or clockwise? STU, you're still going counterclockwise. Okay? So that is called orientation. So that's something to add to your notes. The orientation hasn't changed. Now, if you went from counterclockwise to clockwise, then your orientation's changed. Whenever you do a reflection, a property of a reflection is that the orientation changes. All right? If you were counterclockwise, you would be clockwise. So that's one of those little things that you guys miss on your test because you might, like the 3 people that were just talking a second ago, you usually miss that on your test and you're really upset with yourself. Okay? If you have a neighbor that talks to you during those times, you should probably tell that person to be quiet. When they look at you and start talking, look and go, be quiet. I'm doing my math. Okay? Or don't sit by him anymore. Okay. So if all the people stop moving away from you or start moving away from you, it's because you're talking too much. Usually. Hi, Jeremiah. We're not rotating here. Okay, we're just figuring out orientation right here. All right? So orientation just says what order do you read the letters in. Okay? So orientation hasn't changed. Therefore, this is not a reflection. Automatically have ruled out reflection. So now the transformations you're left with are rotation and translation. So you can either slide it or rotate it or do a combination of them. All right? Talk to your neighbor what you can do there. All right. Hey, guys, so we could move this 5 units up. Could move it 5 units up. If we move 5 units up, that becomes P prime right there. And I'm just going to focus on one point. And then if I rotate that 180 degrees about the origin, P prime, at that point, remember when you rotate 180, that point is all of a sudden going to become S down here. Okay? So what was at the order pair, we have 4, 5, now is down here at the order pair -4, -5. That's one of those properties of a reflection, or excuse me, a rotation is when you rotate 180 degrees. What was AB becomes -A, -B in terms of our coordinates. Okay? So rotate 180 after you translate 5 up. Now we could do that for every point, but if you can get the one point to match all the others, you can check those afterward and see if they match as well. Okay, so you have 5, 5, 1, and -5, -1. So that works out. And you have 2, 2, and -2, -2. That works out as well. All right. Think about orientation. So when you're looking at this next one, number 3, first thing I want you to do, figure out if the orientation changes. The order in which you're reading the letters. Orientation does change. Yeah, we go from A to B to C to D and back to A. So orientation here is counterclockwise. Okay, and then we go from E to F to G to H. Orientation is changed. Here you're going clockwise. So that automatically means you have reflected the shape somehow. At some point you reflected it. Pretty cool, huh? Yeah. All right. So first step, I mean, there are multiple ways you can do it. The first thing I would do is just move it 5 units up. Okay. So, or I guess if we're going A, B, C, D to E, F, G, so we'd have to go 5 down. So 1, 2, 3, 4, 5. That's going to bring point C right here, sharing with that point. And then I can reflect it across this line right here. Or you could reflect it across that line and then slide it 5 units down. What is this line called? X equals 2. So reflected over X equals 2 and then translate 5 units down. So when you're trying to figure out what happens, make sure you're checking. Yeah.
It doesn't have to be that exact
Doesn't have to be. There are multiple ways to get there. Okay? That looked like the most direct way for me. There are other ways you could do it, though. Yeah?
So the order that the letters are in determines whether it's clockwise or counterclockwise?
Correct. The order in which the letters are in determines its orientation. Okay, so remember, this is called orientation. Orientation. All right, questions? I've about hit the time limit I gave myself today, but let's check the other ones. There's 4 and 5. All right, number 4. Determine whether polygons given, vertices, use transformations, explain your reasoning. First one, yes, it's a reflection in the x-axis, same size and same shape. Notice number 5, when you actually do it, I didn't connect these because KLMN doesn't actually form a quadrilateral. Okay, so it has to be the same size and shape. When you get to number 5 and you plot those, that doesn't form a quadrilateral, it forms a triangle. 2 of the points are the same point, K and N. So therefore, no. How many got 4 and 5? Okay, the next one we had was number, number 6, 7, 8, 9, and 10. Tell your neighbor what you got on those.
Which, by the way, I guess on all of these. So I'll make it down.
I guess you're right.
No, but seriously,
That's good.
I guessed it. I don't know why. I came in and I was like, oh my god, I got it right. Because see, look, I was like,
all right.
Question marks, but I was right.
Check them out.
Yes.
Number 6, UV. A translation maps UV to U prime V prime. Okay, a reflection goes to U prime, or I'm sorry, U prime prime V prime prime. So it's a slide there. Okay, which line is perpendicular to U prime? Remember, when you reflect, those points cross your lines of reflection at right angles. Therefore, line K and line M have to be perpendicular to the segment drawn between U and U double prime. Why is V prime prime the image of V? Okay, lines K and line L or M are parallel. Okay, therefore, when you reflect it twice, you get that image. And if the distance between K and M is 5 inches, this distance from V to V prime is twice that. It's 10 inches. The same thing happens when you're dealing with angle of rotation. If this angle right here is 60 degrees, which means this is 60 degrees, that means from A to A prime prime, it's twice that. It's 120 degrees. Okay. Any questions?